Okay, so now here is an example of what can go wrong with these kinds of studies. So what we'll be looking at is an example of what is called Bergson's fallacy. Bergson is the one who quantified the fallacy. An example of sampling error is what this is. So for example, Ray Pearl, about 100 years ago, what he noticed was from autopsy records that very rarely did people die of both cancer and tuberculosis. So he decided that the tuberculosis must be a protector against cancer. So as a treatment for the cancer patients, he proposed to give them the tuberculin. And this was before the days of informed consent and everything. And he actually did it to one patient. The patient passed away, and he was about to do it to a second patient when they put a stop to this. But the question you need to ask yourself there is, who gets autopsied? Is it anybody equally likely to be autopsied? So by looking at autopsies, can you extrapolate from that to general patients? Here's another example. So there were 2,784 people interviewed, and of those, 257 were hospitalized. So let's look at those 257. And what they did is each one of those 257 was classified as either having a circulatory disease or not, no circulatory disease. And similarly classified as to whether they had a respiratory disease or not. And there were 7 of those 257 who had both circulatory and respiratory, 29 who did not have the respiratory but did have a circulatory, 13 who had the respiratory, no circulatory, and 208 who had neither. So now the question is, look at this 2x2 table, and is there any relationship between the row and column classification? And the answer is that the chi-squared is 4.9, so the p-value is less than 0.05, so we reject the hypothesis that there's no relationship between column and row classification. In other words, this sure looks like there is a relationship. The odds ratio, if we calculate that, is 3.86, so it's very big. It's almost 4. And we see what's happening here. If we look at the people with circulatory disease, 7 of them had respiratory disease. So it's probability of like 19%. Whereas of those who had no circulatory disease, the probability of respiratory disease is 6%. Overall it was 8%. So we see that this 8% doesn't divvy up evenly amongst the two categories. So we sure think that there is something going on here. But let's go back to our 2,784. Who were these 287 that we chose of those 2,784? Well, these were the sickest patients. These were the ones who were hospitalized. Is that fair when we're considering respiratory disease and circulatory diseases? Is that fair to just look at these 257? Is there nothing to learn from the other, however many, 2,500? Well, let's see. Let's go back and not look at these, just these. Let's look at everybody in the 2,784. And what do we get? We get that of the 2,784, 22 had both, 2,389 had neither, 171 had no respiratory but had the circulatory, and 202. This time our chi-squared, our x-squared to be compared to the chi-squared is 2.7. Our odds ratio has gone down to 1.52. The p-value is bigger than 0.1, so we do not reject the null hypothesis. So in fact, we see that there's no relationship between respiratory and circulatory diseases, not on the basis of these 2,784 patients. And what do we see? Well, overall, the respiratory rate is 0.08, and now it divvies up into 0.07 and 0.11, so it's not significant. The difference is not significant. So what happened? what happened is we looked at the subsample, those who were more sick than the rest. And in fact, if we looked at how many of those who had both were represented in the hospitalization rate, how many of those who had both respiratory and circulatory, there were 7 of those. 7 of the 22. So it's like a 32% rate. So 32% of those who had both, yes, were in our sample, in our smaller sample, the hospitalized sample, whereas those who had only the circulatory and not the respiratory, 17% of those were hospitalized. Of those who had no circulatory and no respiratory, 8.7% were hospitalized. And of those who had no circulatory and respiratory, 6.4% were hospitalized. So those who were hospitalized, we got a total overrepresentation of this group. Thus, we were getting a distorted view of the relationship between respiratory diseases and circulatory diseases. So that's what Bergson's fallacy is. Bergson's fallacy is you're not getting a representative sample.